we look at the description of the next goal, our next goal is to be able to use graphs and use formulas to understand linear relationships. And so the word relationships here is new. It hasn't showed up in our previous goals for the course. So the first question is, what do we mean by relationship? So what is it that we're actually kind of conceptually going to do? And then, in particular for this standard, what we're most interested in doing is going back and forth between a representation of one of these relationships using a graph, so a set of points on an XY coordinate system, versus a representation of that same relationship using a table of data points, which often, in reality, is where these relationships tend to come from in the first place, as we go out and we collect some data on a couple of different quantities, and then we try to seek a relationship. So we begin with data, and then we try to translate it into one of these other fashions. And then, of course, algebra being algebra, we're also going to want to understand those relationships in a formula. Right, so what do they actually look like if we try to relate them together using the operations of arithmetic that we have at our disposal in algebra? So our goal for this standard is to go back and forth between those different representations of a relationship, which is called a linear relationship between two quantities. So let's get started on the relationship front. I want to take us into marketing land. So those of you who are in business management degree or an accounting degree or just in a business degree in general, one of the common places where this kind of analysis might show up for somebody in business is we're producing a product, we go out into some test markets and we decide to do some test marketing data and figure out if we offer this product for this price, would you buy it? Right? So that's what test marketing is really about, right? Familiarize with potential customers with a product and ask them, would you be willing to pay this many dollars for this product? And they'll say sure, or they'll say no, and you'll collect a bunch of data. And in different markets, you might choose different price points. And ultimately, what comes together is sort of an overall picture of what the market looks like for the product that you're ultimately hoping to sell. So I'm going to pretend for today that we're Apple and that our product is the new iPhone, maybe the iPhone X, right? And if we go out into the market and we do some marketing, some test marketing, then what comes out of that process is a bunch of data points that relate together a quantity, so the number of millions of iPhones that I could sell, right? So we'll call that quantity one of our quantities. We're going to represent that quantity by X in this relationship. And that probably has some relationship to the price that I'm trying to charge, right, for, per unit for my iPhones. So let's presume for the moment that I go into one test market and I ask the people in that test market, would you be willing to spend $500 for an iPhone X? So that makes my Y value here 500. And let's suppose that based on the response rate in that test market, that I find out that if I charge $500 per iPhone, maybe I'll end up being able to sell 75 million iPhones. So what that sets up for me is a single data point. $500 price, 75 million iPhones sold at that price. It gives me 1 point, one snapshot of the relationship between the quantity that we can sell and the price that we want to sell, the price that we want to charge, the price that we want to sell them at. But one data point is not enough to tell us about the relationship between these two things, right? Between the quantity that we'll sell and the price that we charge. What we need is we need to go into a bunch of test markets and try a bunch of different price points and get a bunch of data back. Right? One data point is never enough for us to draw any sorts of conclusions. So we go to another market. Maybe we go to a market where we ask people, okay, maybe not $500, maybe, let's suppose I drop the price some. Let's suppose I want to sell my iPhones for $400 instead. Now, first of all, let's think like marketers for a minute. What's going to happen if I try to lower the price on a quantity I'm trying to sell? Will I end up selling more or will I end up selling less? Yeah, this is one of the basic principles of marketing, is that if we charge less money for the same product, we're going to sell more of that product. So chances are, if I go into a test market at a price point of $400 per iPhone, I'm going to end up being able to sell more than 75 million units. How much more? Well, that's part of the relationship that we're trying to discover. So maybe instead of 75, now maybe I'll somehow be able to sell 85 million units of iPhones at the $400 price point. So what's emerging here is that now I have these two different data points, two different snapshots in my relationship. I have my first data point, which says that at $500, I'm going to sell 75 million iPhones. And I have my second data point that says at a $400 price point, I'm going to sell 85 million iPhones. And I'm placing each one of those two points onto a graph and giving them coordinates in an ordered pair. So this ordered pair, 75, 500, it packages together the x value of this observation, which is the number of millions of iPhones that I'm going to sell. It packages it with the y value that it matches with, which is the price that I'm trying to sell them at. And so each one of these snapshots becomes one point in our xy coordinate system. And we can locate any of those points by first just going from the origin here, where both x and y are 0, going from the origin out to the relevant x value in the horizontal axis, so out from 0 to 75, going this way, and then going north by 500 units to get to the y value. So every step of the way, what we're setting up is this correspondence between the kind of information that we have in our table of data up here and the kind of information that's being carried in this graph in the picture that we're developing. And those two need to tell the same story, even though they're always going to tell it in slightly different ways, right? Drawing a graph is going to help us to connect with information more visually. Having a table of data at our disposal is going to help us to get more numerically precise information. And ultimately, the goal is for us to develop a formula, an actual algebraic equation that relates x and y together, that will allow us to use all the tools that we have in algebra up to this point to really get at that relationship and understand what's going on. And 2 data points is better than 1 for sure, because now at least we can kind of see that as the price that we're charging goes down, the number of phones that we sell appears like it's going to go up. But 2 points is never really enough for us to be absolutely certain of what's going on, so let's also assume that maybe I have a couple more. Maybe I jack up the price point in another market, and I decide to ask, all right, what if I want to sell iPhones for $600 a piece? How many of them am I going to sell? And let's suppose that there my marketing data comes back and says I'm going to sell 65 million at that price point. And so we go and we ask a bunch more markets, how many units are you going to support selling in that market? Maybe I'll drop the price down to 200 over here, and then we end up selling a bunch. Maybe I'll jack the price way up to 900, and then we end up selling a lot less. Right? So we go out and we ask a bunch of different test markets. We get a bunch of different snapshots of prices and quantities, and this makes a relationship that in marketing is called a demand function. So when you hear about supply and demand in marketing and in microeconomics and macroeconomics, this is an example of what's called a demand relationship. It relates together the price that we're trying to charge something together with the quantity that we're going to sell at that price. So this is called a demand function. And what do you notice about the picture that might not be immediately obvious from looking at the table of data? What is the picture suggesting? Or what are some of the stories that you could tell about this picture? One important story that this table is kind of hard to interpret because it looks like sometimes our demand is going up, sometimes going down, it's a little mixed. But on the diagram, on the graph, we can clearly see that as the price goes down, the number of phones that we sell goes up. And vice versa, as the price goes up, so as we move north on this graph, as the price goes up, the number of phones that we're going to sell is going down. So that's the first thing that we notice. And it won't be something that we hang on to for long in this course, but definitely when you get to calculus, when we have a relationship that looks like that, it's called a decreasing function. So this just means that as x goes down, y goes up, and vice versa. Right? So that's one important story that this data is telling us. Can we be even more specific about that? Is there a particular shape or a nature of this relationship that's being suggested by where those points are falling? You might get a hint by looking at the title of this standard. Whoops. goal being to use graphs and formulas not to understand just any relationships, but to understand linear relationships. And if that's what I'm trying to do, what feature of this graph am I looking at? What are these points doing? What shape are they suggesting on this graph that we might be able to use to our advantage? It looks like all these points lie on a nice straight line. So not only is it a decreasing relationship where every time one of these quantities goes down, the other one goes up. That's true, but it's also true that they do so in a very predictable fashion. They do so in a way that anytime I go from one of these points to the next, I'm going to a different point that lies along the same straight line on this graph. And that's nice. That's predictable. That's something that we can encapsulate. That's a pattern. That once we identify what the pattern is, we also will know how to continue that pattern, to make predictions about data points that aren't in our data table. And that's where the real power of this kind of analysis comes in. Because we can collect 6 data points if we want to. But chances are, when this phone goes to market or whatever, we're probably not going to charge exactly one of these prices. We want to find out how to charge, for example, a price which is going to maximize our profit, for example. And that price might not be one of the prices that we already tested. It might be something in between one of these data points. It might be something that's not even within the realm of these data points. It might be somewhere else on this line. But if we know the pattern that this line is suggesting, we'll be able to know exactly where we want to be. And so the power of this analysis is not just in connecting the data table with the graph, but it's also in connecting this graph with what is the underlying pattern that's producing this straight line. How can I come up with a relationship between x and y that's going to tell me not just the locations of these 6 points, but the locations of all the infinitely many points that lie along this entire line? And so that's our last objective here, is how do we get from the information that we have to an equation which is going to tell me specifically how y relates to x. Right? So it's going to be an equation that's going to have both x's and y's in it somehow. And this equation should have the property that when I plug in any of these x values into the equation, and then I solve the equation for y, that equation has to produce for me the same y value that was associated with that x value in the table, and also in the graph. Right? So whatever relationship that we have here, with y's and x's in it, when I feed it a 75 for an x, it needs to spit out a 500 for y. And similarly, when I feed it 105 for x, it needs to spit out 200 for y, and so on and so on. For all the data points that we collected, and for all of the points in between those data points and beyond on the graph.